All right, everybody, this is 1.3, measuring segments. Feel free to pause the video, attempt to do now on your own, and then check your answers for accuracy when you resume the video. First thing I need you to do is draw an example of each. Point B, line AB, and ray DF. Like I said, pause the video, give it a shot on your own, then resume when you're ready. Point B, simplest one, just put your point, label it B. Line AB, well, draw your 2 points. Through any 2 points, there is exactly one straight line, postulate 1-1, A, B. Ray DF, meaning it has a start point and no end point, meaning it continues through, DF. All right, today we're going to be looking at measuring segments. So just a refresher on what a segment is. A segment is a part of a line that consists of 2 endpoints. Okay. Complete each sentence with endpoint, endpoints, line, or points. A ray has 1 endpoint. A line contains infinitely many points. A segment has 2 endpoints. And a segment is part of a line. Postulate 1-5, the ruler postulate. Every point on a line can be paired with a real number. That is called the coordinate of the point. Postulate 1-5, the ruler postulate. So, measuring segment lengths. If you take a look at this number line here, okay, you're going to notice that we're increasing from 0 to 2 to 4 to 6 to 8. So each hash mark on our line represents a spacing of 2. So plug in our missing spaces. In between -2 and -6 would be -4. In between 8 and 12 would be 10. And in between 12 and 16 would be 14. Now it asks us to find the length of UV, which is right here, UV, and SV, which is the entire length from S all the way to V. Okay. So UV is SV, okay, the entire length, minus SU. Okay, so what that means, the entire length minus this portion of the length will give us UV. Okay, so really SV is from -4 to 14. That's a gap of 18 minus SU is -4 to 10, which is 14. So UV is equal to the absolute value of 4. Absolute value means you just take the positive value of that number, meaning distance from 0. So 4 is 4 spaces from 0. So UV must be 4. Okay, another way to solve for UV would be to simply say V is 14 and U is 10. 14 minus 10 is 4, and the absolute value of 4 is 4. Okay. The length of SV, okay, would be -4 for S, and V is 14, so 14 minus -4. When you get those double negatives, it turns into a positive, and 14 plus 4 makes 18. So the length of line SV is 18. Now, in geometry, you're going to have to write justifications when you're proving and solving different questions. So your justification for your first step is the definition of distance. Okay, the first point minus the second point. Okay, simply from line 1, meaning this line here, to line 2, we subtracted 14 minus 10, 14 minus negative 4. And lastly, we found the absolute value. Postulate 1-6, segment addition. If 3 points A, B, and C are collinear, meaning they're on the same line, and B is between A and C, then AB plus BC equals AC. Now, I sort of introduced this to you on the last slide with my first example. But here's your line, A to B to C. There's your line, or your line segment. The gap from here to here is AB. And from here to here is BC. So if you add AB and BC, you get the entire length of the line, which is AC. Using the segment addition postulate, in the diagram above, the length of JL is 120. And if you notice, JL is the entire line. So I'm going to put 120, spanning from J to L. In the diagram above, the length of JL is 120. So if we look on the left, we're trying to prove postulate 1-6, JK plus KL, so from J to K and K to L, will equal the entire length of the line, JL. If you notice, JK is 4x plus 6. So what I wrote for you already is 4x plus 6. KL is 7x plus 15. So we are adding those two things together. And on the right-hand side, you're going to see those lines again. Those are for justifications. JK plus KL equals JL is the segment addition postulate, the one we just wrote down. Then I simply replace JK and KL with their algebraic values. We substituted. Step 3, I'm going to combine like terms. Well, 4x and 7x makes 11x. 6 plus 15 makes 21, which equals 120. Once we combine like terms, we're going to use the addition property of equality. Okay, I see plus 21, I'm going to subtract it on both sides. 21's cancel. Should actually say subtraction, property of equality. What you subtract on one side, you subtract on the other. My 21's cancel, I bring down 11x equals, and 120 minus 21 is 99. Last, we have the division property of equality. We have 11 times x, so I'm going to divide by 11 on both sides, and x equals 9. Okay, now, we've solved for x, but we still have not solved for the length of JK and the length of KL. So we're going to have to do that on the next page. We know that JK was 4x plus 6. KL was 7x plus 15. And we just found out that x is equal to 9. So wherever there is an x, I'm going to plug in the value of 9. JK equals 4 times 9 plus 6. KL equals 7 times 9 plus 15. JK equals 4 times 9 is 36 plus 6. And KL is 7 times 9, which is 63 plus 15. JK equals 42. And KL equals 78. Now, to prove postulate 1-6, those are supposed to add up to 120. So let's find out. Does JK plus KL equal JL? 42 plus 78 needs to equal 120. And if we add these two together, 120 equals 120, it checks out. So we have just proved postulate 1-6 segment addition. For your exit slip, you are going to do the same thing that we just did, the same process, just using different numbers. AB is 20x plus 4, and BC is 10x plus 20. So first, solve for x. Second, solve for AB. And third, solve for BC. All right, and your given is in the top left corner. The entire length of AC is 360. So the entire line from A to C is 360. Okay? Thanks for watching. Don't forget to submit your work.